I'm going to get started here. So my name is Johanson. I am a senior software developer at AWS, where I focus on .NET technology on AWS. And today we're going to talk about creating serverless applications with AWS. So my main goal is to teach you how you can use .NET Core 2.0 with AWS Lambda. AWS Lambda is generally the heart of a serverless application on AWS. And then we're going to take a step back and see what does it take to really build a full serverless application. And if I have time, I'm going to hopefully talk a little bit about how you could do some of this CI/CD systems as well. So AWS Lambda is the heart of your serverless application. This is what's going to provide the compute power to be able to run your serverless applications. It runs your code. So what it is, it's a fully managed compute environment. You basically just give it your package bundle, and you tell Lambda what function in that package bundle invoke. And it takes care of making sure you have all the infrastructure needed to run that code. And it does it on demand. It's going to provide that compute capacity as requests are going to be passed into the system. It's not meant for long-running batch jobs. The most time you can run for per request is 300 seconds. Like I said, it's event-based, so those events can come out from the web HTTP events. So you could front your Lambda functions with Amazon API Gateway, or you could have it being triggered by service events. Many AWS services, like Amazon S3, which is our object storage system, or Amazon DynamoDB, our managed NoSQL system, will signal out events that Lambda will run on based off those events. And you can use that to define some of your workflows to manipulate your database as things change. You can also write custom events. Define your own events, use any of the AWS SDKs, and invoke your Lambda functions passing in those events there. Now, when it comes to billing for Lambda, you're charged just on how much time it takes to actually run your code. You're not provisioning any resources for this. It's just on how long it takes to run your code. You don't have to think about, I need X amount of servers or anything like that. Now, I do spend a lot of my time out there on GitHub helping other .NET developers work with Lambda. And I see that there's still a lot of confusion on how Lambda works. So I kind of wanted to take just sort of a 10,000-foot overview of what's going on under the covers at Lambda. And this is a gross simplification, but hopefully it kind of gives you an idea of what's going on. So imagine here we have our Lambda function deployed, and we get an event. So Lambda's going to take that event, and it's going to go and create a compute environment on the fly to handle that event. And that's where you hear the term cold start, where it actually creates the compute environment. It's going to start up the runtime. In our case for .NET, it's going to start up the .NET Core runtime, and then it's going to process our event. Now, once that event's done and there's nothing else coming in, Lambda just freezes that environment, including any state that you've set up in that .NET Core runtime, any initialization you've done, that's also frozen in there. So if you make another call comes in, Lambda's going to say, well, I have this frozen one. Let's just thaw that out and reuse that one. And that's your warm start, where it's just going to reuse an existing compute environment. And any of the things that you've already cached and initialized will already be set up for you. So when that's done and there's no more events, Lambda will freeze that as well. Now what happens if you get multiple events coming in? In this case, we have 2 events coming in. Lambda's going to take those in. It's going to reuse that one compute environment that it already created, but it doesn't know how long that's going to take to run that. That could take a few milliseconds. That could take 5 minutes. And Lambda is all about horizontal scaling, so we want to make sure we're just working things as much in parallel. So it's just going to go create another compute environment to handle that request. And this is how Lambda really has that horizontal scaling, because it's always going to be creating compute environments to handle the scaled events coming into your system. Now, once it's done, Lambda's going to freeze those environments, and then after some amount of inactivity, Lambda's eventually going to go reclaim those compute environments. Now, what's happening all inside that group box is it's all abstracted away. From your point of view, you're just invoking functions, and you're paying how long it takes to run that code within there, not any of the compute environments that were set aside for that. Now, for .NET Core, which means you're going to create a project that's targeting .NET Core App 2.0, you build that project up, and you would package it up, and you could package it up with .NET Publish. When you run .NET Publish, that copies your application's DLL and any of its dependency DLLs. Now, I highly recommend, though, if you do, use one of our provided tools out there, either the AWS Toolkit for Visual Studio, or we have extensions to the .NET CLI to package this up. Because what we're going to do with our tooling is we're going to optimize the package that .NET Publish creates. For example, when you run .NET Publish, by default, it's going to go and create a publish folder that will work on any environment. It's going to make it so it works on Windows, Mac, and Linux, and include all those dependencies. But when we're using Lambda, we know that this is going to be running on a Linux environment. So we can tell it, .NET Publish, just include the dependencies you need for Linux, which will create you a smaller package bundle. And the smaller package bundle you have, the quicker cold start, or the shorter cold start you will have. Now, when it came for us defining what the programming model was, our main goal was, let's keep it simple. Let's not create a big framework that could be restrictive. We really only wanted you to just tell us, what is the method in that package bundle to call? That's really the framework it is. The signature of that method is pretty flexible. You could take no parameters in there. Maybe this is just a .NET function you want to call on a scheduled basis and it has no input. Or if this is responding to an event, you could have it taken a parameter for that event. Optionally, and most common, you will have it take an iLambda context object. The context object is going to give you information about your running environment. It also has APIs that you can use to do logging as well. Then when you create the function in Lambda, part of the API is you have to specify that function handler string. This is what identifies in that package bundle what method to call. And for .NET, the syntax is passing in the assembly name, double-colon, the type name, and then double-colon the method name. With that information, we figure out what method to call. And because the programming model is so simple, we could also add F# support as well, because it's just a .NET Core runtime that's just looking at that string to find a method. And last week, we shipped new versions of our tooling that allow you to create F# projects for Lambda inside Visual Studio. So that's the overview. Let's take a look at what this would be like actually inside Visual Studio. Here's Visual Studio. I have the AWS Toolkit installed. There we go. Which has this main view. This is Explorer, which allows you to manage some of your resources here. If you don't have the toolkit installed, you can go to Tools, Extensions, Go Online, just search AWS, and there's our toolkit there. So just go and click that and install it. Once you have your account set up, you can click on Add, just add your credentials in here to be able to do your Lambda deployments from here. The toolkit allows you to have multiple profiles in there, so multiple accounts in there, and you give each one a name. The name default has some special meaning to us, because when you create one of the AWS SDKs, it has a whole chain of logic it uses to find where your credentials are. And if, for example, you didn't specify any credentials information and you didn't specify a profile when you set up your SDK, it will go say, oh, do you have a default profile registered on your machine, and just use those credentials. And that way, you're just basically running it based off the credentials provided by your environment and not embedding anything in your actual application. Now, to create a project, we just go File, New, Project. Under C#, we have AWS Lambda, where we have really two different project types in here. We have the Lambda project type, which is where you're going to create a single Lambda function and deploy that to Lambda, and then you go configure your event sources for that. We also have the serverless application where you can deploy multiple resources all together. We're going to take a deeper look at that later. Right now, we're going to do the Lambda project, which, like I said before, we also have these same templates for F# if you have F# developers out there. We're going to do C# here and say Lambda project. And then we have a collection of blueprints that you can use to help get started with some of that initial code for, like, example, listening to S3 events. We could hear a list and create this, to create a Lambda function that has all of that boilerplate code for listening to S3 events. Now, I've actually already created a project. I'm going to just switch over to that to take a look at that. What this project is, it's really the classic example that you see in Lambda. This most example is like, I want to be able to listen to when new images are uploaded to S3 and create a thumbnail for that image. So that's what this project is. So we'll take a look at our code. And the first thing you might notice is we have this serializer assembly attribute. By default, what Lambda knows what to do is to pass you in a stream as your input and take a stream back as a response. But if you register a serializer, it'll actually convert that stream, which is really a stream of a JSON document, into your .NET type. So in our code before, we're going to take an S3 event, not a stream. And that's supported by adding this in there. Now, we have a default constructor for this. If the method that you're pointing to by that function handler is an instance method, then that type has to have a default constructor. And that constructor is only going to be invoked the first time the Lambda function is invoked in that compute environment. So this is where you can do any initial setting up things that you don't want to do for every function invocation. In our case, we were creating an S3 client, and we only want to do that once for our invocation. Let's just take a look at some of the code here. Here's our function handler string. So this is the method that we're actually going to call. It's taking in an S3 event object, and it's asynchronous. So we're going to return back a task. And Lambda is going to basically wait to see when that task says it's done to report back that the Lambda function has completed that event. So then we're going to go make sure that the object uploaded is one of our supported types. This is a hash set of all the extensions that we support. And notice I have all these context logger lines. This is how we can do logging in Lambda, is we can write to the statements here, and every Lambda function has what's called a CloudWatch log group, which captures all of the logging to there. It also captures all of your standard out and standard error. So if you have any console write lines, those will also be written back to the log group as well. Now, because .NET Core doesn't have system.drawing to do image manipulation, to do image manipulation in .NET Core, I'm using this library out here called magic.net, which is using image magic. So that's what this code here is doing, is we're going to download the object from S3 and use image magic to go and create a thumbnail. Now, if you've never used S3, the basic primitives of S3 is you have a bucket that contains all of your objects, and an object has a key that identifies where it is. Now, what I'm doing here is I'm going to say for all the thumbnails, take the last part of the key information, which is just a string, and I want to just put the word thumbnails as a prefix. So this is how I can kind of partition some of the data in my bucket. So this is where thumbnails will go. And then we'll put that object back up. That's our function. Let's take a look at how we would deploy that. We can do that by right-clicking, and we can say publish to AWS Lambda. And a lot of this is already filled out for us. The reason it's filled out as part of our blueprints is we write this defaults file here that has a lot of the initial settings for us set up by the blueprint, which is the name of the assembly and the type and the method name. And as I go through this wizard and I make settings and I have this checked, all the settings I make in the wizard will be saved in that file. So when I do deployments in the future, it'll just reuse all that information. It's also going to allow me to, when I switch to the command line deployment, it will reuse that same file, and I can just use that same deployment back and forth between the toolkit and command line. So let's call this NDC afternoon. Oh, image resizer. I don't know how many times. Number 10. I can't remember how many times I practiced this talk here. So on the next screen, the most important thing we have to do is we have to give it a role. The role is what is basically going to be assigned to our Lambda function, and it was giving the Lambda service to act on our behalf. Because our Lambda function has to access S3. And by default, Lambda just can't go access S3 on our behalf. You have to give it permissions to do it. The role that you assign to it is what gives it that permission. From this dialog box, I could create a new role based on some of the default policies out there. I could also craft one on the IAM console, Identity and Access Management console. I've just already set up a role already. I'm going to just reuse that one. Now, memory here, this is really what it comes with Lambda. This is where your vertical scaling comes into play. As you assign more memory to your Lambda function, it also increases the amount of CPU power your Lambda function is. So this is your slider bar for how much vertical scaling you need. And we can also pass environment variables. But I'm just going to leave everything else on default and just push upload. And so what's going on basically is we're running .NET Publish. We're running Publish with all the parameters to know publish this up to a Linux environment, and then we're telling Lambda to go create a function for us with that bundle. And this is going to bring up our Lambda view, which is going to come up from the Explorer. And from this view, here I could put in a sample request. This is a JSON document representing our sample. And there's examples here of some of them. For example, this is what an S3 put looks like. I could then go fill this in with real values and then just push invoke to invoke our Lambda function. I could audit some of the configurations. I can also go set up some of the event sources. From the toolkit, we have just a few of the event sources you can set up from here. A lot of the other places in AWS, you would go to their console to get those configured. So for us, we want to configure an S3 bucket to listen to this. So first, let's go create an S3 bucket. So this is the norm images. Someone has already claimed that bucket. And so every bucket name is global unique, so we're going to call this norm images NDC. Surely no one has taken that one. Okay, so that bucket is created. And now we can just go in here and say, I want to use the S3 event type, and I want to say, here's my bucket. And I don't want every object uploaded to this bucket. I don't want every object in this bucket sent into our Lambda function. I only want ones that have a prefix in their object key of images. So when I upload anything into my S3 bucket, which has an object key and the start of that is images, it'll invoke our Lambda function. Push OK. And so now it's all configured and set up for us to go. So if we go open our bucket up here, I'm going to create a folder called images. I have some sample images here. Upload all those. So this is uploading. So you can see here's this image on full size. Any Soundgarden fans, this is the original Black Hole Sun in Seattle. My kids are climbing all over it there. That should have run. And if we go now up here, we should see here's our thumbnails folder. Because our Lambda function just picked up those events and created our thumbnail. So if we click on our Black Hole Sun now, we can see now we have that small one. So we didn't have to deploy any compute environments. We just deployed our Lambda function, set up that event source, and it got all that configured for us. If we look back at our functions view, we can go to logs, refresh that. We can see we have a lot of logs, actually. And we click on these, we can see it was processing. The reason we're seeing so many different log files is this goes again back to how Lambda is horizontally scaling. We send in a bunch of events all at once to Lambda, and Lambda didn't wait till one image is done and then work on the next one. It created multiple compute environments, and each compute environment has its own log stream for that. So that's how you can see how it did scale out that way. And the last thing I wanted to show before we switch back to slides is if we look at the CSproj file, one of the things we add in there is this reference to Amazon Lambda tools. And this is a .NET CLI tool reference. This is what allows us to switch back and forth very easily between Visual Studio and the command line. It's also the trigger we're using in the toolkit to know when to show that publish option. Basically, our logic in the toolkit is this project a .NET Core project, and does it reference Amazon Lambda tools? If it does, then we assume this is something you intend to deploy to Lambda. And so if we go to the command line, I can say .NET Lambda, if I just do that, we can see here's some of the commands that you can do from the command line. And that deploy function is the same one we just did in the wizard. And because everything got written to that defaults file of everything we saved, there's the function name and the handler, I can actually just say .NET Lambda deploy function, and I don't have to pass any of the arguments. It'll just rerun that same deployment. I can override any of the settings in that file by passing those arguments on the command line, though. Okay. One more thing, though. We created a project from Visual Studio. You can also create a Lambda project from the command line as well. We have a package out there called Amazon Lambda Templates that you can install with the .NET New command, .NET New -I in the package name. Once you do that, then all those same Lambda projects that we have in Visual Studio are available from the command line as well. So now that we know how we can create a Lambda function, a serverless application is usually a lot more than just a single Lambda function. It's usually made up of several Lambda functions and other AWS resources. A common anatomy of a serverless application is you would use AWS Lambda for your compute power. And then for storage, you'd probably use Amazon S3 as object storage, or maybe Amazon DynamoDB as our managed NoSQL database. In a serverless application, you're also having lots of different pieces, and they're usually working asynchronously. You have to work on how you're going to communicate between all those. Communication, we have Amazon SQL Simple Queue Service for your queues, and Simple Notification Service to broadcast messages with topics. As well as we also have all those service events as well to manage your communication. Now, if you have a large workflow that you want to build, something that just can't really be done in just one Lambda function, you can use AWS step functions to define that workflow that you're building as a state machine and have it mapped to all your Lambda functions for each stage it needs to go through that. Now, because we have multiple AWS resources we're going to go, we need to make sure that everything is connected up the right way. We really don't want to go clicking through all the different consoles to make sure all this is set up. We want an easy, repeatable way to deploy this. AWS CloudFormation is the AWS tool to use for this. Basically, what you do is you write a template file, which can be written in either JSON or YAML, that declares these are all the resources I need, and these are how they're connected up as well. And then when you deploy them, it's called a stack. And it's going to create all those resources just as one unit. And this is really great for your dev test cycle when I want to go create my own personal stack of everything, go run this, instantiate this template, do my testing, and then I can just delete the stack, and it'll take care of clearing out all those resources that I created, so we didn't just leave anything else orphaned in our account. Now, to demonstrate a serverless application, I wrote a demo application that we're going to walk through. It's called my Video Tag Cloud Generator. What the goal of this is we're going to take a URL of some video from somewhere online and generate a tag cloud of what's being said in that video. We're going to do that all serverless. Now, to do that conversion, though, that's going to potentially take a long time, especially depending on how long that video is. So this is where we're going to define a state machine that manages the flow of that conversion from a video to our tag cloud. I'm not going to dive too much into this slide because we're going to jump just into the code and see how this all works. So let's go. And I'm going to point out, too, at the end of this slide, I'm going to have a link to all the code that I'm going to demo for everybody, if anyone wants to see that, because I don't have time to go through every part of it. So here's my first project. This is my step functions project. And I created this from that wizard up there. I said new project, AWS Lambda serverless. And I have my step functions blueprint there to help me get set up for that. Now, this project is different in the Lambda project in that it contains a CloudFormation template, which is going to be the driver for our deployment. And for the step functions ones, we also have a state machine.json file that defines the whole workflow that we're going to use for this machine. Now, I just have the JSON one here. In the console, they actually have a designer for this. But I'm going to take a look at the JSON one because I think it gives a better clear what's going on underneath the covers. So here we're going to start off saying, what point in our state machine are we going to start with? And it's going to start with our transfer video to S3 task, which says each one of these nodes have a type. This one is a type task. A task is something that a Lambda function is going to handle. So when it gets to the state, it's going to invoke this Lambda function. Let's take a look at that Lambda function. So that encode here is just going to close this down. It's going to call this code here to basically go and download our video from somewhere and upload it to S3. In the Lambda environment, you always have access to writing to the temp folder. So that's where your temporary storage can be. Now notice in this Lambda function, I am taking in a state object and returning back a state object. This is a class that I wrote for my state machine. And it contains all the information that I need while it's going through this workflow. My inputs into this is I needed essentially the display name of this video, I want some unique ID for this video that I can refer to later, and what's the URL that I want to convert to. Now, every one of the Lambda functions part of my state machine, they're going to take the state object in as its input, and they're going to return it back out. And that's how we can keep the state running through our whole workflow. And we can add more data to it. So we can see, I think it's in the upload here. On the state object, I'm setting the link to the S3 URI. So that's how we can build up our state there. And then this is now we need to transcribe this. Once it's in S3, we need to get the transcript out of it. And we have a service called Amazon Transcribe, which will take a link to a video in S3 and will create us a transcript for it. Now that can take a while to run depending on the video. So let's just take a look. So that Lambda function, we're going to take that same state object in. Using our transcribe service, we're going to go start a job. And we're going to record the name of that job. So this is just all we're going to do in that node is just start at that job. And now we need to go see how long. We have to stay at this point in our state machine until that is complete. How we do that is, first we're just going to sleep for 5 seconds. So that's the next stage. We'll sleep. And then after that, we're going to call our get tasks, or get status for our transcription task, transcribe task. And that just does a simply get on that. Using our client, we're going to go list our jobs, passing in the name of our job, and we're going to go set the job status based off of what the service returned. And we're setting it on that state object with that transcription job status. Now, if we look at our state machine, we can have, it's going to move next to this conditional step, or choice type, which we can look at our state object. This is using a JSON path, because that's how step functions treat all your state as a JSON document. We can use a JSON path in there to see if it's currently equal to complete, let's move on to the next step. If it's still in progress, let's have it go back in a loop, back to the sleep state. So we can keep pulling on this with our step functions until that job is done. Then once that's done, we'll go into our processing our output, which is where we're basically going to go take our transcript and copy to our S3 bucket, and another function that's going to go and examine our transcript to find all of our common terms that we'll use in our our tag class. Now, I'm not going to go through all that code. It's pretty similar to the same before. Again, all the code is available to you if you want to get deeper into that. But so now we want to deploy this. And this is a CloudFormation deployment. I'm going to deploy it first, and then we'll take a look at the CloudFormation template while it's deploying. So we're going to right-click there. And then deployment is a little different in this case, because now we're not deploying a single function. We're deploying a CloudFormation template, which creates a stack. So we've got to give it a stack name. So this is NDC tag cloud. And then we have to give it S3 bucket. The reason we're giving S3 bucket is when we're doing deployment is we're building that package bundle, and we're going to upload that package bundle to S3, and then we're going to go modify the CloudFormation template for all of our Lambda functions in there and say where is the code for that, where we just put it up in S3. I'm just going to push publish and let that go. So this is going to do that build and then upload to S3. So now it's initiating with CloudFormation to say, go create this stack. And it launches the stack view, which is going to start returning back events of all these resources coming online. While that's doing that, let's take a look at the CloudFormation template. So here, define all of our resources here. We've got 5 Lambda functions we're deploying. An S3 bucket we are creating, an IAM role to give our permissions for our Lambda functions, and as well as defining our state machine. Creating the bucket was very simple. We didn't have to set any properties. We left the name empty because we wanted to generate a name so we can make sure every time we deploy it's a unique name. When it comes to defining the Lambda function, here's that function handler string that we showed before. This is what identifies in our package bundle what is the name of the method we want to call. Here's where we're going to refer to the role that we're creating down below. This is what's going to assign permissions to it. I should mention too, this is our CloudFormation in Visual Studio where we do actually have IntelliSense as well for a lot of things. We also are passing in environment variables. So this is, we created a bucket up before, but our code needs to know what's the name of the bucket to use. So we're passing the name of that bucket as an environment variable into our Lambda function. So then in my code, I have my utility code that's going to go look to grab that bucket out of the environment variable. And so that's how my code knows which bucket to use for storing all of its tag cloud information. Now the code stuff, this is blank, like I mentioned before, and the deployment code went through this file after it uploaded S3 and updated those fields to where it just put up our deployment package. Now the other Lambda function declarations are very similar, just really changing the function header strings. Here's our IAM role that we have created. This is where basically we have to allow the Lambda service to give it permissions to assume a role for us. And then these are the permissions it's allowed to access for us. It can access the transcribe service, it can access the S3 service, and this one also gives it access to writing CloudWatch logs. This one is still pretty permissive permissions. If I really wanted to lock down, I could lock this down to individual actions as well as individual resources, so it could only access just the resources that I want. The other one I want to show here is, this is our state machine definition. Notice here that the state machine definition is actually blank. One of the features that we added to our .NET tooling is we wanted to give you the ability to define your state machine in a separate file instead of trying to fit that in there. So we had it written in the other file, and then in that defaults file, we have this parameter called template substitution, which allows us with a JSON path point to that and say replace what that's pointing to the contents in this file. This is allowing us to compose a CloudFormation template with multiple files. Now the last two parameters I want to talk about is, this is the first part of our serverless application. It's creating our state machine, it's creating our bucket, and other parts of our application need to be able to find out what is our state machine and what is our bucket that we're using. So we're going to publish that information out to what's called the parameter store. And with that, then our other parts of our serverless application can then go look up that information to find out where do I go start an execution at, or where do I go get my S3 bucket information. So this should all be deployed now. It should have actually gone pretty quick. So it finished at 1:30:01, at least Seattle time, and then 1:20. So it took about a minute to create all those resources for us. Now, if we were to go to the step function console, here's the state machine that we just created with our CloudFormation template. And I can start an execution here. And so the state going through execution is a JSON document, so which is going to be serialized into our .NET state object. So I have a sample of what that would look like. So we have to specify the video name and an ID for it and some video. So let's go out to TED Talks and see if we can find video. Let's see what Bill Gates is up to. I'll take his video, copy that link. And call this Bill Gates. And we just need some unique ID. We're going to call this first video. Then we'll start that up. And that's going to begin our execution. And we can actually see how that execution is going through our system on this console. So we can see all those steps that we define in that JSON file here. We can also see, so right now it's busy copying that file to S3. We can look here, and we can see this is the inputs that were passed into it, into that state. And if that's complete, we'd get an output that, in this case, is going to have filled in the S3 URL for us. Okay. So while this is creating our first video, let's keep moving on. Oh, we can see the first stage is now complete. And we got an S3 URL for that. So now that we have our serverless backend creating our tag cloud information, we want to expose a REST API so that we can create our client, whether this is a mobile app or web app. So we're going to create an a REST API using Amazon API Gateway. And there's 3 APIs we really have to care about here. We want an API get to get all of the tag summary information. We want to get a get to get all the individual details, all the tag categories for a particular one. And we want to be able to post to this API so we can start new jobs. Now, each of these APIs can be backed by different resources. In our case, we're going to back everything up with Lambda functions. You could have some of these backed up with some load balanced application, or an EC2 instances, or S3 buckets, or just some other HTTP endpoint out there. Now, one of the interesting things that we've been working on in our .NET Core and Lambda tooling is the ability to run ASP.NET Core as an actual Lambda function. Instead of running it as a web service application, just run it as a Lambda function. This allows us to basically reuse the common framework that we know with ASP.NET Core, all those extensions and middleware for it. We don't have to learn a new programming model. Local development is really easy because we all know how to just do F5 for ASP.NET Core application and debug from there. When we launched the .NET Core 1.0 support, we launched this part as preview. One of the biggest drawbacks, though, was the package bundle size, because you included all of the ASP.NET Core dependencies. But with 2.0, there has that package store in there, which means all the ASP.NET Core dependencies are already pre-installed in the target environment, and they're pre-JITted for that environment as well. So when we run .NET Publish, it doesn't include any of the ASP.NET Core dependencies, which means we can still have a small package bundle and have a reduced cold start time. Now, this is made available because we have a package out there called Amazon Lambda ASP.NET Core Server. This NuGet package basically makes it so we can replace Kestrel, which is the default web server for an ASP.NET Core application, with Amazon API Gateway. It handles all of the conversions of the request responses between Amazon API Gateway and ASP.NET Core. So let's go create our web API now. So here is our ASP.NET Core application. It's very similar to any ASP.NET Core application you have. If you want to take an existing ASP.NET Core application, you basically add that NuGet package out there and that .NET Lambda tools reference into your CS proj file. If you want to create a new one with everything pre-configured, you would say add new project, serverless again, and then we have a blueprint for the web API. We also have a blueprint that's also a full ASP.NET Core app with Razor pages and things like that. The main difference this is between the regular ASP.NET Core blueprint or project template, is we renamed program CS file, which is that initial file that does the bootstrap for your web host. We renamed that to local entry point just to signify that you use this for when you're doing your local development. But when you're running in Lambda, it's the Lambda entry point that's being used. So this is the entry point that starts everything. It's sort of replacing what would be done typically in the program CS file. And all this code is doing is going to inherit from the base class in that NuGet package. And the one method that you need to override is the init method, which you typically then would want to add the startup class. So this is the minimum you have to do. In fact, in this project, the only Lambda-specific code I have is just this code right here. Everything else is just standard ASP.NET Core code. So here is my tag controller. So here's my get for all. And then we have a get all the individual data. And then I have a post, so I can post new jobs. So this is where I'm going to take from the web, I'm going to take my name in my video. I'm going to create a state object, generating a new unique ID, and then start an execution. This is going to kick off the first thing that we deployed, execution engine. Now to deploy this, we have a CloudFormation template. I'm going to deploy this again first, and then we'll look at the CloudFormation template as it's deploying out. So deploy that. NDC tag web API. I'm going to give it a bucket to store things in. Now this template has parameters coming in. This is identifying what were the parameter store names that we want to grab for the state machine and the storage, the S3 bucket. So that's how we're transferring that information here. So this is how I could have had a beta and a gamma and just pass in different names for these. I'm leaving everything as the default, but you could see how you could have different stages for this. And we'll publish. So that's going to go spin that up. Now, if we look at our template, this template is actually pretty simple. Up here is those parameters that we declared. That says these parameters are coming. The value of these are going to come from the name of the parameter store variable. Which I don't think I showed. Let me quickly show where that was at. I go back to the console, EC2 parameter store. These were the variables that were set up during that first deployment. And these are the ones that are going to get sucked out as part of this CloudFormation template and put into our code. Now, we only have one resource we're creating in this one. It's called a serverless function, which is actually sort of a meta resource. Because it's going to create lots of other resources out of it. It's going to create our Lambda function. It's going to set up our IAM role. And in the events section here, it's also going to define how this Lambda function is going to be connected to its event source. In this case, we are going to connect it to an API. So it's going to go create a API gateway REST API. And for the path, we're using this proxy syntax. What this is saying is for all requests coming into our REST API, starting with /, go and just send that request into our Lambda function. Because we're running an ASP.NET Core application, we're going to let ASP.NET Core handle the routing to our write controller in our code. We're not going to let it be done by API Gateway. I also have the environment variables coming in. So this is how we're going to pass into our application, use this execution, this state machine, and use this S3 bucket for your information. And because ASP.NET Core, environment variables are just part of the configuration system, we look at our configuration, our controller, we took in the iConfiguration object, and we just asked out of the config object to give me the state machine arg. So that's how we're able to pass that configuration between our different parts of the application. Now we should all be deployed. Again, this took about a minute to do. I have a URL. I'm going to launch Postman up here. Test this out. API tag clouds. And so here we are calling our REST API ASP.NET Core application serverlessly. We got back the first video that we launched initially. We got a complete date, which tells me that that video has gone through the whole workflow system for it. We can also start creating more jobs. Let's do a post. I have some. This is a Soccer and Freedoms TED Talk. Post that one. And that's to send back its ID. And let's do one more. Growing fresh air. And we'll run that. So now we've added 2 more executions going on to our application. So our REST API did the post, which submitted the execution job, and now our state machine is running through its own workflow for those videos. Yeah. Now that we've done that, we should also see, if we do a get, now we get all 3. The ones that we just submitted, the complete dates, no, because they're still in progress. Okay. So now we've got our backend, we have our web API. Now for me, we have to do the scariest part, which is the front end. That is always very daunting to me. But one of the things I always like doing about these talks is it gives me an excuse to go and try new technology. And so what I think has been really, really interesting and can play very key into the service platform is how would Blazor fit into this? Steve Sanderson gave a great talk earlier today showing a lot of its good benefits of essentially it's going to allow us to run C# and Razor pages actually in the browser using WebAssembly. And the initial fear is this another Silverlight? But this is actually all using standards that the browser is already implementing. So for me to get this to work, I didn't install anything in my browser. Still pretty early days for Blazor. 0.3 version came out last week. There's no debugging yet in Visual Studio, so this did, for me to create this front end, I did have to get back to doing print statements all over the place to find out where things are going. And the print statements showed up in the browser's developer tools, because it's all running there. Now, the reason I thought this would be interesting, though, is because we're talking about serverless, and if Blazor is not even needing any compute power, then all we just really need is just something to host our static data, which that's where Amazon S3 works really great at, because Amazon S3 is a perfect tool for delivering static content. And you can configure your S3 buckets to basically act like a website. And it works really well with the fact that we have a ASP.NET Core Lambda backend as well to do all of our computational work back there, and we can keep with our .NET tooling on the client side. So let's see how I did with this. So I don't want to go, I'm assuming a lot of you probably went to Steve's talk today, so I'm not going to cover, we'll try to repeat everything he said because he did a much better job than I would have done. But this is basically looks pretty similar to ASP.NET application. We have Razor pages. I have 2 in this case. An index page, which is going at the root, which basically has a form. Give me the video name and the URL. And on the button click, I'm going to go and submit a job to my REST API. And then the other video, or the other Razor page, is going to go on this thing and taking the parameter of the ID. And when the ID is set, we're going to go load the data. And for me, this was cool because the data might not be available yet. So what I did is I just started using the .NET constructs that I've always been using is I set up a timer and then kept polling, making that REST call until I got the data I wanted. The one thing I need to do before I run this, though, is I have to put in the URL to the API we just deployed. So that is here. And when I run this locally, basically what it does, the local development of ours is it spins up a mini ASP.NET Core server that's returning back the static content of our Blazor application. Oh. And things are early days with Blazor. One of the things I have found, and I keep forgetting to clean up, is if you currently saw both your debug and release folder, it gets confused. Doesn't know which bin folder to use, which I'm sure will be fixed. So here is now our Blazor application. I didn't veer too much from the initial project template if you've seen that, but it's showing here's our Bill Gates blue tag cloud, where he is talking about money and problems in California. The soccer one. Soccer's talking about freedom and immigration, growing plants and percent. So this has all been generated serverlessly through application. But now we still have to figure out how we're going to do the front end serverlessly. And so let's deploy that. So first we need to do is we need to do a .NET publish on it. I'm going to go to the command line. And I'm going to do .NET publish -c. I spelled publish correctly. Then release mode, which is why I keep having bin in release. Okay, so now that is created. We go look in release, publish. So this is all of our static content that we just need to host now in AWS. And the easiest way to do that is to just use S3 for that. So I'm going to go create another bucket. This is my NDC UI 1, because someone's probably already clicking the other bucket. I'm just going to go and copy this over. Now, if I was doing a real deployment, I would script this out, but Blazor, we're all cutting edge and still coming up with what's the right chain of tools you would use. That's all copied over there. While that's copying over, the one change we need to make to the bucket, if we click on properties, is we have a website property. Here I can just say I want to enable this as a website. I have to say what is the default page, the index page, HTML. That's created as part of the Blazor blueprint, which has essentially the bootstrap code to launch Blazor. save that. And that's all uploaded. So if we click our link, we now have a serverless Blazor application talking to our serverless ASP.NET Core application that's been using our serverless state machine to process all of our video and create tag clouds for all of the interesting things out there. All right. Now, for CI/CD, we have a couple options out of the box that AWS supports. Although you can always make any of your own. When using AWS services, the main services we have a whole code suite of services. Code commit is the Git source control provider. Code build is our Docker-based build system, which is, again, kind of another serverless platform because, again, you're just saying, I want to run a build with this instruction file and this Docker image, and it runs everything. You don't set up the machines for it. Code pipelines allows you to connect your source, your build, and your deployments all together. It doesn't have to be using the AWS services. You can use other services like GitHub or Jenkins when using this. A pipeline for a serverless deployment would look something like this, where you're going to take your source, code commit is your source, and your build, you're going to use our command line tools. You'd run that dotnet Lambda package CI command. What that does is it's going to do all the building of your application, upload that to S3, modify your CloudFormation template to point to that, and then pass that CloudFormation to your deploy stage, which is where you're going to use CloudFormation to do the actual rollout of your application. Now, the other thing that we have, because we know there's a lot of .NET developers use VSTS, Visual Studio Team Services, or they're using TFS on-premise, is we also released a set of extensions or tasks that you can add to your account and be able to do these deployments from here. So we have a lot of ones for the common services as well. In fact, if I still have this open, here is my build definition that is set up to go and say, this is my stack name, my S3 bucket, and where my code is, my project is. We have a lot of other tasks as well. And this is an open source project that we are always taking input on and what else should we be adding to it. That was the demo I was going to do. So that is the recap here. So hopefully you learned a lot about Lambda, how that works, how you can build a service application, use CloudFormation template for that, use step functions if you have large processes you want to build out. I highly recommend getting started with the toolkit. We've got a lot of tools to help you get started there. If you're not using Visual Studio, you can use the Amazon Lambda tools from the command line and the Amazon Lambda templates to create projects from there. And with that, one link I want to point out here, this is the link to all the material I did show it off today. So I just pushed this out to GitHub. It contains all the slides if you want the slides, as well as the demo code as well. So you're welcome to that code as well. I am also on Twitter. My name is SocketNorm on Twitter. If you ever have any AWS.NET questions, feel free to always reach out to me. If you have any questions while you're at the conference and you want to get together, go ahead, just reach out to me, then we can get together and talk there. I am one of the main contributors to the .NET developer blog there, and these are some of the GitHub projects that I work on. If you're doing .NET Lambda, that first one is probably going to be the most useful one of where to get help at. With that, thanks, and be sure to put the speaker evaluation